I'm here to talk about lazycogs. I'm going to give like a really lightning fast lightning talk intro to lazycogs and why it exists and what it is. And this brings me back to when I first kind of heard about the Pangeo community, which is um, basically I discovered STAC because I was doing forest analytics stuff using satellite imagery and other data sources and had a lot of code that had to glue together raster files, and then discovered STAC and then STAC and got really excited about that. But then tried managing Dask clusters and was like not as excited anymore. That was hard. So I started trying to distribute work in different ways. And I always ran into scaling issues with Dask clusters and probably user error most of the way. But yeah, that was the goal. It's kind of like the abstracted access to many, many raster files. And that was back in, I don't know, 2021 or 2022. And a lot has changed since then. And I've been working on the STAC-GeoParquet ecosystem. Pete Godomsky's RustStack package makes it possible to query STAC-GeoParquet like an API. And there are some new tools out there that, like async-geotiff, that make it possible to read COG files or any geotiff file without GDAL, which I love GDAL, it's great, but in some use cases, you don't need all of GDAL. And for STAC-GeoParquet, especially, like it's hard to use GDAL effectively. So I was trying to do some stuff with that and got kind of stumped and decided to take a different route. And so that's where lazycogs comes in. So lazycogs lets you run a stack query. And here, I'm just going to pull up a notebook. Using RustStack, it's really easy to save a stack search to Parquet. So like I have an area of interest, time and space. I can do a very inclusive stack search to get all the stack items for that. Then do some introspection, look at the items, figure out some, what are the details about the projection in this area, the size of the files, the resolution, and so on. And lazycogs gives you an interface really similar to StackStack and ODC Stack to open an array from a STAC-GeoParquet data set. You can provide stack search filters or sorting keys for the mosaic operations, but it's all really fast, especially up front, where with StackStack, you had to materialize all the stack items into memory. And then, if you're running a Dask cluster, potentially transfer all of that to your Dask scheduler. With lazycogs, it's reading Parquet files, which could be local or in object storage. And then once you have the array open, it's very familiar. You've got an XY array with a band dimension and a time dimension. And you can do all the things you could do with all your favorite tools, make plots, and so on and so forth. I'm going to show this other example using HLS data, Harmonized Landsat Sentinel. We've got a Hive partitioned archive of all the stack records that the HLS granule production pipeline creates, sitting in S3. And we can use that with RustStack in place if you have access to that bucket. I'm working on making that completely public. It's semi-public right now. But here, I'm just going to scroll down here to when we open the array. This is all available in this notebook is on the lazycogs documentation site if you want to take a closer look later. But here we've got a huge array, which is a year and a half's worth of HLS granules from the Sentinel collection, HLS S30, for an area of interest that I defined here. And opening the array is pretty much instantaneous because it's just got to scan the stack records for the temporal extent. And then all the lower level operations are reading cogs just in time. And yeah, that's the story. I think I'm running low on time. But yeah, there's a lot of work to be done in terms of clarifying the best access patterns for doing point samples or generating chips, things like that for machine learning applications. But yeah, I'd love it if people try it, push it to the limit, see what's working, what's not working. Yeah, that's the talk.